natin silang pilitin makipag Hello, good evening, everyone. What I'm doing right now is I'm trying to configure multi-stream in OBS. So I downloaded a plugin and configured the stream key and the URL of different platforms. I can see it on YouTube and at the same time on Twitch, but I'm not sure with 17 live because I cannot see myself live in there. Okay, so for today's stream, I'm gonna discuss about the SQL joins. SQL joins. For the recap of the previous lessons, we've discussed about the inner joins and the outer joins, the cross joins and the sub joins. So we finished details on inner join, the joining with alias tables using an action, relationships in database, then multiple joins, joining multiple tables and checking multi-table joins. Then for the outer joins, cross joins and sub joins, we've discussed about the left and right joins, then building on the left join and the full join, the chaining of full joins and crossing into cross joins. So after all the joins, after all the joining in SQL, we're now here on the union versus union all. I hope you can still remember the lesson because I've streamed for I think about more than a week ago. I guess it's been 10 days since my last stream, and here I am. Here I am again. If you have any questions on the lesson, please feel free to message me on the chat box. So for the lesson, let's hear from Maham Faisal Khan.
Back for Chapter 3. In this chapter, we explore a new way of joining data, set operations. Along the way, we'll highlight key differences between set operations and the joins we've seen so far. SQL has three main set operations: union, intersect, and except. The Venn diagrams shown visualize the differences between them. We can think of each circle as representing a table. The green parts represent what is included after the set operation is performed on each pair of tables. In this lesson, we'll cover union and union all. Let's take a closer look at how they work. In SQL, the union operator takes two tables as input and returns all records from both tables. The diagram shows two tables, left and right, and performing a union returns all records. The diagram shows two tables. In SQL, the union operator takes two tables as input and returns all records from both.
It says that in SQL, the union takes two tables as input and returns all records from both tables. So the left table here has 5 records and 1 and 4. 1, 4, 5, 6. Okay, so it says here that a union takes two tables as input and returns all records from both tables. So the left table here has 5 records and the right table has 4 records. However, 2 of the records were identical. So the result after the union is it returned 7 records in all.
Tables. The diagram shows two tables, left and right, and performing a union returns all records in each table. If 2 records are identical, union only returns them once. To illustrate this, the first 2 records of the right table have been faded out. Our result has 7 records. In SQL, there is a further operator for unions called union all. In contrast to union, given the same 2 tables, union all will include duplicate records. Therefore, performing union all on this data will return 9 records, whereas union only returned 7. No records have been faded out. The syntax for performing all the set operations in this chapter is highly similar. We perform a select statement on our first table, a select statement on our second table, and specify a set operation, in this example either union or union all, between them. Note that set operations do not require a field to join on. This is because they do not do quite the same thing as join operations we covered in earlier courses. Rather than comparing and merging on the left and right, they stack fields on top of one another. For all set operations, the number of selected columns and their respective data types must be identical. For instance, we can't stack a number field on top of a character field. The result will only use field names, or aliases if used, of the first select statement in the query. We now return to our word on top of a character field, the number of selected columns as join operations we covered in earlier courses. Rather than comparing and merging on the left and right, they stack fields on top of one another. For all set operations, the number of selected columns and their respective data types must be identical. For instance, we can't stack a number field on top of a character field. The result will only use field names, or aliases if used, of the first select statement in the query. We now return to our world leaders example. In this example, we use one more table from our leaders database, the monarchs table. Of course, this table is only a sample of monarchs and not a comprehensive list of monarchs across the world. We can use union on the monarchs and prime ministers tables to show all the different prime ministers and monarchs in these two tables. Note that the monarch field has been aliased as leader. As we've learned, the monarch and prime minister fields will be combined under the leader field, even though we only aliased the monarch field. We'll limit to the first 10 results so they fit on our screen. Our union returns the top 10 monarchs, prime ministers, and their corresponding countries. Does something stand out here? Recall that the monarchs for Oman and Brunei are also prime ministers. Union only lists them once each because they are the same person. Norway is listed twice, however, because its monarch and prime minister are different people. This is where a union all is helpful. A union all will tell us if there are any monarchs who also act as prime ministers. The syntax for this is shown. After union all, Brunei and Oman are now listed twice. Ready for some exercises? Let's look at some more applications of union compared to union all.
Okay, let's do the exercises. So the difference between the union and the union all is with the union, it only returned the number of records combining the two tables, but with same records. Same records would only be counted as one, whereas with union all, there would have duplicate records. So for the exercises, it says here that two tables, the languages and currencies here. This is the table for the currencies and the table for languages. So the tables are provided, and it says run the queries provided in the console. So here's the query. Okay, let's go back to the first. So it says here that we have to select the query is select asterisk from languages, then union with select asterisk from currencies. Then let's run the code and let's see what the result is. Languages. Languages. Let's run the code. Select asterisk from languages. Select asterisk from okay. So it has an error because the question here is what result will the following SQL query produce? So it says here that the union query must have the same number of columns. So the answer should be SQL error because languages and currencies do not have the same number of fields. With the tables, the columns and fields are equivalent. Columns are equivalent to fields. So this is the answer. And then for the second instruction, just have to copy the code. Select code from union all. Select code from select code from union all. Select code from parentheses. Then run the code. Select code from select code from the table name was omitted. So it says here select code from languages. The tables were the languages and currencies. So we have to select the code from the table languages, then union all with select code from currencies. Then run the code and it shows 100 out of 1,979 rows. So the answer here, the question was, what result will the following SQL query produce? So the result here has duplicate records, and it is not in order because, as you can see, if we browse on the records, there's letter D, DZA, then followed by ASM. So it is not in ascending order. It is not in order. So the answer would be an unordered list of each country code in languages and currencies, including duplicates. Then, for the third question, what will the following SQL query produce? So again, let's copy the code provided. Select code from languages. Select code from languages. So the query is select code from languages, union, select current ID from currencies. Then let's see what result it will return. So it generated an error because so the answer here is an SQL error because code and current ID are not of the same data type. Not the same data type. So it states here in character varying and integer cannot be matched. So this is the answer. Then as we go on with the exercises. I'm not sure is this stream on. recorded. I'm not sure. So, moving on, with Twitch and YouTube, I think it's okay, but 17 live, I don't know if it's streaming on live. So, okay, for the next exercise, comparing global economies. Ready to perform set operations. So it says here that in this exercise we have two tables: economies of 2015 and economies of 2019. Available to us under the tabs in the console here. Economies table, economies of 2019 and economies of 2015. 2015, okay. So let's inspect the tables. Code year, income group savings. Okay. So it has the same structure, the same columns and the same, of course, the same columns, but different data within. So what we'll do here is we'll perform a set operation, stack all records in these two tables on top of each other, excluding duplicates. So excluding duplicates. So I guess from the previous lesson, using the union all union all command will return duplicates. So I think we have to use the union clause. So it says here that when drafting queries containing set operations, it is often helpful to write the queries on either side of the operation first, and then call the set operator. The instructions are ordered accordingly. So we have to begin our query by selecting all fields from economies. So we're going to use the previous lessons commands, okay, for the select. How do we select all fields? So to select all fields, we have to use select asterisk. Asterisk denotes all. Select asterisk from economies 2015. Okay, and then okay. We have to finish first all the instructions before we run the code. Okay. Because the lines here will generate an error. So create a second query that selects all fields from economies 2019. And then perform a set operation to combine the two queries you just created, ensuring that we do not return duplicates. Okay. We have to be mindful of our. So let's see. There has no duplicates. So I think we generated the right amount of the right result. So let's submit the answer. Check the select statement. Could not find the first entry in the left operand. Could not find the first entry. That's the thing. Okay. The correct set operator to use here is union. Tama, union. We call the set operations required to call the operator between the two select statements and do not require you to specify any columns to join on. Select asterisk one columns. Tama naman. Okay. So, actually, the answer, my code is correct, but the solution provided here is the solution provided here disregarded the first two instructions and focuses only on the third instruction. So my answer was the first line was to select all fields from economies, and the second line was select all fields from economies. The first line was I selected all the fields from the economies 2015 table. Then the second line, I selected all the fields from the economies 2019 table. But for the third line, so it has to be just a single query. What I did was I created three queries. So, but it generated the same result. Okay. Because with exams like this, instructions like this, the computer just takes on what is saved as the should be the duplicate, what should be exact result. So if you have any alternative solutions, it was not counted as correct. Anyway, what's important is that we realize what the problem is. Okay, so moving on with the lesson, comparing two set operations. So we have learned from the video exercise that union all returns duplicates, whereas union does not. In this exercise, we will dive deeper into these working out cases for when union is appropriate compared to union all. Okay. So we have to see when we have to use the union and when we have to use the union all. So we will be looking at combinations of country code and year from the economies and populations table. So let's inspect on the tables. The populations table is, it has 6 columns, whereas the economies table has 1, 2, 3, 4, 5, 6, 7, 8, 10, 11 columns. A common from column which is common is the code of the country. Okay, country code. So for the instructions, perform an appropriate set operation that determines all pairs of country code and year in that order. Perform an appropriate set operation that determines all pairs of country code and year. So order by country code, order by code, comma, year. From economies and populations, excluding duplicates. So it is stated here that excluding for the first instruction, if we have to exclude the duplicates, we have to use the union clause. Economies and populations. I've forgotten the previous lessons from the previous because I think it's been 10 days. 10 days from my last lesson. Remember that with you I'm learning. Because so we have select the economies. Again, it does not generate any error. Okay. It's right. Then after that, amend the query to return all combinations, including duplicates. Amend the query to return all combinations, including duplicates of country code. Okay. So to include the duplicates, we have that. Let's see first. Yay! Okay.
Welcome back. In this lesson, we'll explore our next set operation, intersect. Intersect takes two tables as input and returns only the records that exist in both tables. In the diagram shown, we have two tables, left table and right table. The result of performing intersect on these tables is only the records common to both tables, the first record. All records that are not of interest to the intersect operation are faded out. The syntax for this set operation is very similar to that of union and union all. We perform a select statement on our first table, a select statement on our second table, and specify our set operator between them. Let's compare intersect to performing an inner join on two fields with identical field names. Similar to union, for a record to be returned, intersect requires all fields to match, since in set operations we do not specify any fields to match on. This is also why it requires the left and right table to have the same number of columns in order to compare records. In the figure shown, only records where both columns match are returned. In inner join similar to intersect, only results where both fields match are returned. Inner join will return duplicate values, whereas intersect will only.
Intersect versus inner join follows. For the intersect syntax, select asterisk from the table. Intersect, select asterisk from right table. And for the inner join syntax, select asterisk from the left table, then inner join right table. Left table, intersect, select asterisk from right table. So after it returns one record, whereas for the inner join syntax, it returns two records, duplicate. Somehow confused with the inner join here. So the inner join first takes on gets all the values from the left table, then compare it with the right table. Whereas for the for the intersect, it cross matches both the records from the left and the right, and counted as one. For the inner join, it is always with reference to the left table. So here the left table has two duplicate values, and it returned those two duplicate values into two records. Okay.
Return common records once. As we know from earlier lessons, inner join will add more columns to the result set. Let's have a look at how we can use intersect to determine all countries that have both a prime minister and a president. Each select statement in our query has the same number of columns of identical data types. In order for the set operation to be performed. The result of the query is the 4 countries with both a prime minister and a president in our leaders database. As with union, the result set uses the field names provided for the left table, whether aliased or not. Next, let's think about what would happen if we selected 2 columns, country and prime minister, instead of just country, as in our previous example. The code shown does just that. What will the result of this query be? Will this also give us the names of countries that have both a prime minister and a president? The actual result is an empty table. Why is that? As we saw in our intersect diagrams, intersect requires data from both fields in the left table to match their corresponding fields in the right table. The search did not find any countries where the prime minister and president share the same name. However, recall that there are monarchs in our database who also act as prime ministers. In the example shown, performing an intersect on the prime ministers and monarchs tables using both country and leader name does not return an empty result. Let's get some practice.
So for the instruction, we have to return all cities with the same name as country. Let's check on the tables first. The table here are cities and countries. So we have to return the records with the same name. The Forward. Then, which of the following definition of set operations is correct? Union returns all records in both. Potentially duplicates in both records. No. Union all returns only unique records. No. Intersect returns only records appearing in both tables. So it has to be this. Okay, so this is that. Intersect is a robust set operation for finding the set of identical records between two sets of records.
Way to go! We are now at the last of our set operations in this course. Except allows us to identify the records that are present in one table but not the other. More specifically, it retains only records from the left table that are not present in the right table. The diagram shown illustrates the workings of the except operation. All records that are not of interest to the except operation are faded out. Only the last two records of the left table are returned. Note that while the ID 4 does exist in the right table, the whole record does not match, which is why the last record of left table is not faded out. We saw earlier that there are some monarchs that also act as the prime minister for their country. Let's say we were interested in monarchs that do not also hold the title of prime minister. The except clause is really handy for this. The SQL code shown selects the monarch and country field from monarchs and then looks for common entries in the prime minister and country fields in the prime minister's table, looking to exclude those entries. In the result, we see only the 3 monarchs from our leaders database who do not also serve the role of prime minister. Well done getting through all the lessons on set operations.
Says here that just as we are about to leverage intersect to find the number of cities with the same number of countries, we can also do the reverse using except. So in this exercise, we have to find the names of cities that do not have the same names as their countries. So it's the reverse of the intersect. So for the instruction, we have to return all cities that do not have the same name as country. Have to run the code. Done. Okay, so it's just the reverse of intersect. Exceptional. If the countries had been on the left and cities on the right, that's the opposite. Okay. So what's next? What's next is calling all set operators. So now we've made our way to the challenge problem for this chapter. Then to test our knowledge of set operators in SQL by classifying the below use cases into the correct buckets. So think of how the information in each use case could be stored as tables, and recall the Venn diagram we have learned. Okay, so for the union all, it gets all the data. For the intersect, it gets only the common data, the data common between the two tables. For the union and union all, it gets all. For the intersect, only the common, and for the except, only the records not appearing on the other table. Okay. So drag and drop the use cases provided into the correct set operator. So we have to Residence Hall has asked students to rank their preferences to be assigned a room. Now they want to pair students based on common preferences. Common. I think the keyword here is the common. For the common, it has to be on the intersect. We run a music streaming service and has a list of songs the user has listened to. You want to show them new songs they haven't heard before. So they haven't heard before. It should be accepted. Then you are a school teacher teaching multiple classes. You would like to combine the grades of all students into one consolidated sheet. So you need all. Okay. Okay, let's try. One chapter to go.
We've made it to the final chapter of this course. Keep up the excellent work. In this lesson, we'll return to joins one last time with an introduction to nested SQL queries. The 6 joins we've worked with so far are all additive in that they add columns to the original left table. The diagram shows an inner join on the ID field, showing an additional column being added to the original left table. Here's some familiar inner join syntax for this join on the ID field. Let's dive deeper into what it means for this join to be additive. Fields with different names are added to the results set with their original names. Fields with the same name, such as date, are added to the results set too, But notice how we now have duplicate date columns with the same name. This can be changed, however, with aliasing. In this lesson, we'll see ways of joining data that do not expressly use join keywords and are not additive in the same way. Instead of using join or set operators, we can leverage the where clause to specify the records to include. We'll use the two tables, left table and right table, in the diagram shown. A semi-join chooses records in the first table where a condition is met in the second table. More specifically, the semi-join will return all values of left table where values of call 1 are in a column we specify, namely call 2 in the right table. Records not of interest to the semi-join have been faded out. The final result of our semi-join is records corresponding to IDs 2 and 3. Let's make this concrete with an example. Suppose we're interested in determining the presidents of countries that gained independence before 1800. We select the fields country, continent, and president. How do we filter this data for independence year, which is a field in the states table? We'll use a semi-join. Before we knew anything about joins, we knew we could leverage the where clause to filter data. The query that returns countries with independence year before 1800 is shown. The query returns only Spain and Portugal from our database. We can use this list of countries as a filter by embedding it in a further where clause. This is called a subquery. It chooses records in the first table where the country matches the list returned by our subquery. Since Spain does not have a president, only the Portuguese president is listed. Moving on to anti-joins. The anti-join chooses records in the first table where column 1 does not find a match in column 2. The final result of our anti-join is records corresponding to IDs 1 and 4. Again, no new columns are added. How might we adapt our semi-join to determine countries in the Americas founded after 1800? To change our semi-join from before to after 1800, we add not before the in statement. We call this an anti-join. In addition, we add to our first where clause to filter for continents in the Americas. The result shows presidents of countries in the Americas that gained independence after 1800. Only Chile and Uruguay are returned, not the USA, which gained independence before 1800. Note again that we are only using the few countries in our database for illustration. This is not a comprehensive list of countries in the world. Let's practice.
Multiple word clauses. We have learned about semi-joins and form of nested subqueries within the word clause domain query. So in this exercise, we'll have to familiarize ourselves with semi-join syntax by thinking through and reordering the lines of code provided. Note that subqueries are queries in their own right, so they can have a word clause of their own. This is why we have to see we see two word statements. Okay, so there were two word statements, and to select and to from. Okay, so our task here is to construct a semi-join that pulls all records from Economist 2019, where the gross savings in the Economist 2015 table were below the 2015 global average. The global average gross savings in 2015 was... Wait, what happened? Okay. Was, okay, the gross The global average gross savings in 2015 was 22.5 and it's already pre-calculated with the lines of code provided. So for the instructions, we order the lines of code provided, find all records from Economist 2019 where gross savings in Economist 2015 were below the 2015 global average, using code to filter the Economist's 2019 records. So select to find all records. So select asterisk is the first. So wait. Instruction tama. Reorder the lines of code to find all records from Economist 2015. So select asterisk from Economist 2015 where code in select code from Economist 2015 where gross savings less than 22.5. So I think this is the right order. Select asterisk from Economist 2019 where code in select code from Economist 2015 where gross savings is less than 2.5. Okay, nicely done. But I'm not done. So, semi-join. So after getting acquainted with semi-joins and anti-joins, you are now going to have to practice using semi-joins. So let's say that you are interested in identifying languages spoken in the Middle East. The languages table contains information about languages and countries, but it does not tell us what region the countries belong to. As always, studying makes me sleepy. So we can build up a semi-join by filtering the countries table by particular region, and then using this to further filter the languages table. How far do we have to go before I can sing? We have to reach the finish line. 1, 2, 3, 4, 5, 6, 7, 8. Still have a lot. Select country, go to countries in the Middle East. Second query, to select the name of each unique language appearing in the languages table. Unique, unique is distinct. Order languages. I have to see, I have to see, I have to see. Order the name of the languages. I have to finish this so that I can see. Order the name of the languages. Order by name, ascending order, ascending, ascending. Ascending. You do not have to specify it unless it is descending. Then create a semi-join out of the queries we've written. I'll set up the use bracketed subquery below as a filter. Languages. The code. Select code. Okay. Countries for each of course Middle East. Okay. The code in. Okay, so we're done. We're done with another. Then next topic is diagnosing problems using anti-join. Anti. So it says here that anti-join is a related and powerful joining tool. It can be particularly useful for identifying whether an incorrect number of records appear in a join. So if you are interested in identifying currencies of oceanic countries, we have then the following inner join, which returns 15 records. Okay. So the code here. Now we want to ensure that all oceanic countries from the countries table are included in this result. We'll have to do this in the first step. Select code and name of countries for Ocean. So we have to select code countries from Ocean. From countries. So for the instructions, begin by writing a query to return the code and name in order. Code and name. For all countries in the continent of Ontario. Okay. So from countries where continent ocean is ocean. So it returns 19 records. Whereas Are creating anti-join by adding an additional filter to return every country code that is not included in the currencies table. So select code name of countries for continent, filter for countries not included in the brackets subquery. Yay! Just how far are we gone? Yay, we're on the
In this lesson, we'll dive deeper into embedding queries within queries. We'll revisit subqueries within a where clause and then go on to subqueries within a select statement. The semi-joins and anti-joins we've seen so far involve subqueries inside where. The where clause is the most common place for subqueries because filtering data is one of the most common data manipulation tasks. Let's revisit this with some generic syntax and understand the nuances of this type of subquery. Have a look at the query shown. Recall that the where-in clause enables us to provide a list of values to filter on. As we've seen in the lesson on semi-joins, arguments to the in operator are not limited to lists typed out by us. We can include a SQL subquery as an argument for the in operator, provided the result of the subquery is of the same data type as the field we're filtering on.
The query shown will only work if sum underscore field is of the same data type as sum underscore numeric underscore field, because the result of the subquery will be a numeric field.
Subqueries inside where can be from the same table or from a different table, and here the subquery is from a different table. The second most common type of subquery is inside a select clause. Say we want to count the number of monarchs listed in the monarchs table for each continent in the states table. Again, let's build up our solution step by step. The query shown selects each of the 5 continents in the states table, and the result is displayed. In earlier courses, we've seen the use of group by to count data by a group. However, since our monarchs data lives in a different table in the states table, this would involve a careful join before the group by. Let's look at how to do this with a subquery instead. Our subquery requires 2 things. First, it needs to count all monarchs. Second, it needs a where statement matching the continent fields in the 2 tables. This subquery follows the selection of distinct continents and will therefore count all monarchs within them in the select statement. A subquery inside a select statement like this requires an alias, like monarch underscore count here. Magic. Test your subquery expertise with a few exercises. See you in the next video on subqueries inside the from clause.
magic. We'll do some magic here. Select average life expectancy from the populations table. So subquery inside word. Says here that the video pointed out that subqueries inside word can either be from the same table or a different table. So in this exercise, we have to nest a subquery from the populations table inside another query from the same table populations. We have to nest the subquery from the populations table inside another query from the same table. So our goal is to figure out which countries had high average life expectancies in 2015. So it says here that we can use the sequel to do calculations for us. Suppose we only want records from 2015 with life expectancy above 1.15 times the average life expectancy. So we can do the following query. I have to finish so that I can sing. So select average life expectancy. Select masters from populations, then this is your filter not only those populations where life expectancy is 1.15 times higher than average. From populations where life expectancy is greater than One, two, three, four, five, six, seven. Still have that. I have finish at 1:30. Select. So for the next exercise, we have to strengthen our knowledge of subquerying by identifying capital cities in order of largest to smallest population. Follow the instructions below to get the urban area population for cities, capital cities only. We'll have to use the countries and cities tables displayed in the console to help identify columns of interest as we build our query. So return the name, country code, and urban area pop for all capital cities. Urban area. So three on the tables, country state. Name, name. The capital field in the country's table only for capital cities. Campus city. So what name control the council is for name in city capital. Capital of countries. Countries. Six topics. Find top 9 topics with the most. I don't care. So for the next exercise, we have sub-3 inside select. So it says here that there are multiple ways to produce the same result in SQL. So sub-queries can provide an alternative to drawings to obtain the same result. So we'll have to go further in exploring how some queries can be written using either a join or a subquery. So in step 1, we'll have to begin with the left join combined with the group by to select the countries with the most cities appearing in the cities table, along with a count of 3 cities. In step 2, we'll have to write a query that returns the same results as the join, but leveraging a nested query instead. Write a left join with countries on the left and cities on the right. Join in country.
The last type of subquery we'll cover is a query inside a from clause. Let's dig in. Let's say we're interested in all the continents with monarchs, along with the most recent country to gain independence in that continent. A starting SQL query to pull all the most recent independence years by continent is shown. The query groups records by continent and returns the most recent independence year for each group by using the max function as most_recent. The result set is shown. Now, how do we filter this for continents with monarchs? We haven't seen yet that we can include multiple tables in a from clause by adding a comma between them. In the SQL syntax shown, we include two different tables, left table and right table, in our from clause. The diagram shown illustrates that this query returns duplicates for multiple occurrences of ID when it matches in both tables. We can drop duplicates using the distinct command in the query shown. Let's investigate a way to solve our problem using this trick. We can nest the subquery we initially wrote into a from statement so that we are selecting from both monarchs and our subquery, aliased as sub. We also use the where clause as before to identify records in both tables that match on continent. As we saw on the previous slide, because the continents from our subquery will find multiple matches in monarchs, this match will return duplicates. As before, in our select statement, we use the distinct command to drop duplicate continents and select sub.mostRecent to get the most recent independence year for each continent. Lastly, we order by continent. Have a look at our result set. There we have it, the continents with monarchs in our database and the most recent year of independence in those continents. That's how we include a subquery as a temporary table in our from clause and then select from it. We are very close to the end of the course. Awesome work on making it this far. The remaining exercises are designed to be challenging as they put together many of the topics we've learned so far. Stick with it.
Guess I have to continue this some other time. I'm already super sleepy.